Hello everyone, my name is Julie Wynn, and I'm from the Tribology group at Argonne. And I have a confession to make. Before I started this internship, I didn't know what tribology was. Do you? What is tribology and how does it apply to our lives? Let's figure this out together. Today, I will share my experience working with ANL's tribo group, also known as Materials for Harsh Conditions. First, I'll give a brief overview of tribology, then share my summer project at Argonne, and finally conclude with some tribological applications. As I've said from the beginning, I didn't know what tribology was before I started working here, but like any good intern, I did my research. So according to the Wikipedia page, tribology includes the study and application of the principles of friction, lubrication, and wear. Okay, how about some context? The word tribology comes from the Greek verb tribo, which means I rub. Basically, tribologists study the rubbing effects in moving mechanical systems. This field, however, has only recently been established in the 1960s. And in industries such as transportation and manufacturing, tribologists are concerned with optimizing energy efficiency, aka friction, durability, also known as wear, and environmental compatibility. And that's tribology in a nutshell for you. However, I do have another confession to make. You see, I didn't know if I would fit in the tribo group. Up until that point, I had only done biochemical research, lots of pipetting fluids, zero experience with metals. I failed to see how organic chemistry could make me relevant to a group of material scientists and mechanical engineers, which leads me to my project this summer. I study how different lubricants affect friction and wear in hydraulic pumps. We are searching for a biodegradable base fluid that will perform equal, if not better, to commercially available hydraulic fluids. And the base oils I study are a palm oil fatty acid methyl ester and a synthetic polyalpha olefin. Now, a FAME is quite biodegradable, while a FAME is not, PAO is not, but we're investigating if combining the two will yield a better biolubricant. And we're so interested in using bio-based lubricants because these hydraulic pumps will be used in off-road vehicles such as excavators and skidders. And if these machines are used in a forest preserve, we don't want them to leak lubricants that poison the ecosystems they're introduced to. And let's take a closer look at a hydraulic pump. This is an axial piston pump, which is commonly used in construction. My project studies wear on the valve plate, and lubricant exists between the rotating cylinder block and the stationary plate, which leads me to my actual lab work. I've included pictures of me in lab as proof I worked there, just in case 2.75 minutes into my talk you guys still didn't believe me. This machine here is the Nanovia, and I fit a brass ball into the arm and rotate a cast iron flat underneath it. Taking a closer look at the experiment zone, we can see this rotating motion replicates the cast iron cylinder block's rotation against the brass valve plate in the axial piston pump. And a heat lamp ensures the test is run at appropriate pump operating conditions. And after an experiment, I imaged the resulting wear scars using an optical microscope and profilometer. This is the optical microscope, and from the screen we can see the brass is soft and pitted. And the dark raised film you see there indicates the presence of a tribal film. And what's a tribal film, you might ask? Well, they're solid films that act as a protective barrier between the ball and the flat. And their characteristics depend largely on the conditions present. Basically, they're the result of a multitude of chemical reactions, many of which we don't know. And because conditions greatly influence tribal film formation, measuring wear can be fickle. These are all wear scars from the same lubricant, but they're quite different looking. Adding chemicals to the base fluid can stabilize behavior, but we are currently studying fluids free of additives. And like I've said, our research is still in the preliminary stages. Since a biodegradable lubricant is not as stable as a traditional one, our challenge is to formulate a base fluid that will still happily run in a machine for months or years at a time at modestly high temperatures. It's a balancing act. And our project's search for a biodegradable hydraulic fluid is just one facet of tribology. Going back to the Wikipedia page, we can see it extends way beyond metal systems. There's biotribology, geotribology, nanotribology, space tribology. So what is tribology? Honestly, like the Force, tribology is everywhere. It extends beyond metal on metal rubbing. It's applied in the shoes we use to walk, in our contact lenses, even in the way surfaces are designed to feel to the touch. I hope you'll appreciate with me just how interdisciplinary tribology is. There are material scientists and physicists in our tribo group, and chemical engineers in training. This is probably the happiest person you'll ever see holding a capillary tube. But enough about us. What about you? How do you fit in tribology? Join us and find out. The ANL Tribology group is amazing, and we're taking applications for next spring. Hopefully my talk has whetted your appetite to learn more, and thank you for listening. Yeah.
We have time for 2 or 3 questions for Julie. Does anyone have any questions? Nobody? No questions? Going once? Going twice? Oh, yeah. No, we'll leave this for the report.
So I know you said you knew nothing about tribology going into this. Has studying this field changed your entrance and like your future outlook of what you want to do with like graduate school or things like that?
Yeah, honestly, I've never done material work before, but I definitely want to do that for graduate work. And I don't know, if I had done more hands-on work before I picked my major, maybe I wouldn't be a chemie, but chemies are cool, so.
Any other questions? We're good? Okay. Thank you very much.
Thank you.